Hi everybody. So today we will be working on a new topic, and this is now going to be about how to use graphs to relate two quantities. And so our goal is to represent mathematical relationships using graphs. Okay, so let's have a situation. And so here we have a graph that shows the volume of air in a balloon as you blow it up until it pops, okay? So according to this graph, what are the variables and what do describe how the variables are related at certain points of the graph, okay? So as you can see, we have two kinds of variables for this particular graph. We have time, okay? So our variables are t, which is time, okay? And as you can see, it is on the x-axis. So these are independent variables, okay? So these are your inputs. And then the volume, that's another kind of variable. So that's our v, and that's the volume. Now, as you can see, the value of the volume increases as time passes by. So what do those representations here mean, okay? So as time passes by, when you are blowing a balloon, what can you say about the size of the balloon? So as you can see, this part here, okay, every time there's an increase on your graph, it means that you are blowing air into the balloon. And so what happens? The volume is increasing, correct? Now, what can you say about what do those breaks here? Why is there a horizontal line here? Well, definitely you cannot blow your balloon all continuously, right? You always have to have some break to inhale, and then you can get that some more air. And so this line over here, this break here, is when you have your breaks. Okay, so typically that's when you inhale to get some more air. And then what happens next to your balloon? Now you continue blowing it up, right? And as you can see, the volume, your balloon gets bigger and bigger, okay? So you blow, you break, you inhale. You blow again, and then you inhale some more air, you blow again, and then you inhale some more, you break, and then you once you blow the air and the point that it pops, okay? So there will always be a certain limit as to how much air you can put into your balloon. And so once it pops, that's that point, okay? As you can see, automatically the volume of the balloon drops. Okay, so this is the point where the balloon pops because of too much air inside it. Okay, so that is how you can analyze what this graph means based on the situation that you are given. Okay, so let's have two more examples here. So as you can see, we have two other graphs mentioned here. We have the board length and also the cell phone cost, okay? So if you're going to take a look at the first graph here, so what are our two variables, okay? Again, we are looking at time, okay? So this is another variable, so we can have that as our t. And what are we trying to compare as time passes by? We are trying to compare the length of a board, okay, like a wood, or I don't know, it could be a paper as well too, okay? So L is our other variable, okay? This is the length, I should say. All right, so what does this mean, okay? How are we going to interpret this particular graph, okay? Now remember, when you get a board, a wood, let's think about a plywood, all right? You get a wood, it has a specific measurement, correct? Okay, so let's say the length of your board is, let's say 10 feet. I know it's really, really big, okay? So let's say it's a 10 foot board, okay? That length will stay the same. When will it change? The moment that you make a cut, okay? Let's say you saw it, you use, I don't know, however you want to cut it, okay? So every time you make a cut, what happens to the length of your board? It shortens, okay? So as you can see, there is that decrease now, Okay, so let's say you're using a saw. The moment that you are cutting it, okay, it takes a little bit time, and then the moment it snaps again, okay, so that's another cut again. All right, so as you can see, the length is consistent. The length is consistent, and every time you complete a cut, that's when your length changes. Okay, so the length changes over time based on the number of cuts that you are making on the board. All right, now for this other example here, as you can see, this is a cell phone cost. I think this is going to be I don't know if this is going still to be applicable nowadays, because typically you have unlimited number of minutes of calls. But a few years back, there's a certain limit as to how many minutes you are allowed to make phone calls under your plan. Okay, so this is your best representation of that. Okay, so let's say you are to pay $50. Okay, you are consistently using your phone, you are to pay $50 up to, let's say, 100 minutes of call. I'm just making it up. Okay, so let's say it is until 100 minutes of calls. Okay, so up to this time you have been using your phone calls, you hit the 100 minutes. So what happens now to the cell phone plan that you have to pay for? Okay, because you are exceeding your 100 minutes, your allotted number of minutes, then of course, every time you make the next phone call, the cost that you have to pay for your phone will be higher. Okay, so every minute that you exceed the given limit that you have here, that is going to be an additional payment for your phone line. Okay, so that's what these examples mean. Okay.